All right, we got 5-4 today. We're going to be talking about how to graph parabolas in a different way, and we're also going to be graphing sideways parabolas here. So let's talk here about a parabola. A parabola is a set of all points in a plane that are the same distance from a fixed line and a fixed point not on the line. That fixed point is called the focus of the parabola, and the fixed line is called the directrix, and we got some pictures down below. The distance between the vertex and the focus is the focal length of the parabola. So you got a couple of different things here. What this really means is any point on this parabola should be the same distance from the focus as this line down here below, the directrix. And you can do that with any point on the parabola. Doesn't matter where the point is. It should be the same distance. You can even do one kind of like that right there. Okay. And you can do that with sideways parabolas. We're going to be graphing those, and we'll talk about what the equations look like here in just a second. So, depending on if it's opening up or down, notice you're going to use your normal vertex form of a parabola. We've seen that for a while. But what's different here is over here on the right, where it's x equals. Notice everything is switched about it. Instead of y, you got x. Instead of hing x in the parentheses, you got y and k. And then you got the h on the outside. Now the vertex we're still going to write is h comma k. You just got to know that that is now switched. Okay, and then your axis is symmetry on a up and down parabola. That'll always be an x equals line right there because that's a vertical line. On a sideways parabola, that'll be a horizontal line. That'll be a y equals. Okay, and then what else you got? You got the focus point. The focus point is always going to be p units away from your vertex usually. So p is let's write that. Let's write it up here at the top. P is the distance, and you can say the distance from vertex to the focus, or the distance from the vertex to the directrix. It should be the same. Okay, so to figure out where your focus is, we'll use that p distance here in just a second. Okay, the directrix is going to always be the other direction right there, and it'll always be in the form like y equals some number or x equals some number. And then down here at the bottom here, you got a couple of different things. You have this LR. It's actually kind of a funny thing. It's called a latus rectum, and I believe that's lattice or Latin, if I can talk. But yeah, so it's Latin for certain length on certain points between two lines here, and we'll talk about what that actually looks like when we start graphing them here in a second. So I'll refer to that, but I'm going to call it LR. And then you have this formula right here. You got P. Your P distance is 1 over 4 times your A value from your equation. Or you can use this modified version of that if you solve for A instead, and you can say A equals 1 over 4P. And depending on how the problem is set up, sometimes one of those formulas is more convenient than the other one. So we're going to jump right into it here and kind of referring back and forth to this list here. So you'll see me scrolling up and down quite a bit when we're doing these here. So it looks overwhelming at first. It's really not that bad here. So let's start out with a regular y equals line right here, since we already kind of know what those look like. Your vertex is h and k. The h and k are in their normal spots when it's equal to y. So if it's y equals, everything will be normal. All right, and then it's always opposite of whatever your sign is inside the parentheses. So the vertex will be 1 comma negative 4. And that means your axis of symmetry goes through the x of your vertex. That will be x equals 1. And then now to get our p distance right here. So this will be the distance from our vertex to our focus here eventually. And what I'm going to do is use that formula here. We had a equals 1 over 4p. And you can also do the one that's p equals 1 over 4a. They are both the same equation here. But I'm going to use this one here, because what I'll do here is I'll say a, in this case, our a is 1/4. So I'm going to say 1/4 equals 1 over 4 times p. And then you guys learned in Algebra 1, and maybe even here before that, to solve a proportion like this, we cross multiply. 1 times 4p is just 4p. 1 times 4 is equal to 4. And then we divide, and that's going to tell us that our P distance is 1. That's going to help us actually go and graph this graph right here. So typically I will start these on the vertex. So that would be 1 comma negative 4. So that'd be, what is that, down here. And then afterwards, the axis of symmetry, if you want to go ahead and plot that, I guess you could. Get a couple of points here. All right, and then the focus point is going to be 1 unit away. Now, as far as if it's opening up or down, that'll tell us which direction the focus is going to be. So this graph, it opens upward since your A value right here is positive. So that means your focus is also going to go upward 1 unit. That's because of our P distance right there. 1 unit above, that's where your focus is. I'm going to label that as an F. And then down here, I'm going to label my vertex with a V. Okay. Now the last thing we need to go and do to get 2 additional points on our graph is we need to graph this thing called the LR. Okay, and then the LR points right there, we get those LR points from doing 4 times P. That's how long the LR is going to be. So 4 times P right there. 4 times P is actually going to be 4 times 1, which happens to be 4. And what that means is this segment in our circle or in our parabola needs to be 4 total units long going through the focus point. Right there. So notice there, that segment that I just graphed right there, that's 4 units long. And that means our parabola is going to go through that right there. So you have your vertex, and then you have your LR distance. It should be 4 units total length right there. And that's because of 4 times P. And then that's your graph right there. And then domain and range. Domain, these go from negative infinity to infinity, left and right forever. Your range, the lowest it goes is negative 4, so I'll say from negative 4 and then up forever, so we'll go to infinity. And that's how you do these problems here. And then it's going to be kind of like a rinse and repeat thing throughout here. So I guess the newer stuff here is finding your p-value, which you use this formula up here at the top, and then your LR distance. And I'll probably go back here and label this LR. So your LR will be different every time. That's just a common segment that will happen every time if you do 4 times your p-value with these. Okay, so let's try another one out here. I think we're going to do an x equals version here on this one here. So with this, if you want to go back here to your formulas here on the front page, everything is switched about these x equals graphs right here. So I accidentally had it already written in here, but the h and k are switched. So k is now inside with the y and h is on the outside. And inside the parentheses, you still want to go to the opposite sign. So whatever that is right there, that's apparently going to be negative 1 right there. That's where that piece of the vertex is going to be. And then the h was negative 2 on the outside. So opposite sign inside of your parentheses. Okay, now since it's an x equals graph right here, that means your axis of symmetry is going to be a y equals line. And it's going to be tied to this piece right here, y equals apparently negative 1. It's going to go through your vertex. Just make sure it's a horizontal line through your vertex. I'm going to go ahead and start plotting some of those points there. Negative 2, negative 1. It's going to be over here. Your horizontal line, your axis of symmetry, kind of looks like that. And then here in a second, I guess we're going to go get our focus point. Oh yeah, we need to find our P, I guess, first. So we'll use that formula, A equals 1 over 4 times P. And in this case, A is 1/8. Okay, from there, I'm going to cross multiply. That'd be 4P times 1 is 4P. And then 8 times 1 is 8. Which now means when you divide, P is 2. Which means your focus and directrix is 2 units away. And actually, now that I'm kind of thinking about it, I forgot to graph my directrix right there. So I'm going to go back and get that here in just a second. But really, I need to get in the habit of writing that out each time there. So anyway, so this graph will be different. It's going to be opening either left or right. And in this case here, x is positive. So positive A here means it opens towards the right side. So we're going to go ahead and plot a few points here. So 2 units away from your vertex, here's your vertex, I'll label that V. 2 units away is your focus. Okay, and then you're going to go and get your LR. So we get the LR points. LR is always going to be 4 times your P value. So 4 times 2, which would be 8. Now you need the LR to be 8 total units. So I'm going to do half of that above the focus and half of that below. So I'm going to go up 4 units. I think that'd be up here. And then down 4 units. That's going to be down there. And then sketch your graph from there. That's typically all we're going to graph on these. And then let me go back and do a better job here of getting the directrix. The directrix line is the same distance, the same P distance, from your vertex to your focus is 2 units. So from your vertex to your directrix needs to be 2 units as well. And then I'll do another dotted line kind of like that. Typically I'll do a dotted line for the directrix. And then theoretically every point on the parabola should be the same distance from the directrix as the focus right there. So if you go count, that should be 4 total units there. And that's how you're going to do these here. So don't forget about your directrix. By the way, your directrix line is the line, that's a vertical line, x equals -4. If you want to go back and add those. Yeah, so let's actually add that in here. Directrix x equals -4. Domain, these are a little bit different here. The left, most of the graph goes as -2, and that's tied to your vertex. So -2 and then to infinity. And then the range, it actually goes up and down forever. So the range now is -infinity to infinity. And that's going to be it there. Let's go back and get the directrix here on this previous problem. So let me go back here. P was 1 unit, so if your focus is 1 unit away from your vertex, then your directrix needs to be 1 unit away from your vertex as well, which looks like it's through the line y equals -5. And then let's go add that in. That's the directrix. Usually we'll abbreviate it DIR. That's y equals -5. All right, that's it there. All right, let's do some more here. Another y equals graph. So h and k are going to be in their normal spots. There's h, there's k. And then I guess we'll go opposite sign of the h piece. That's -4. And then -3. Axis of symmetry goes through the x on these here. If you're not sure, just graph it and you'll be able to see. Okay, your p distance. So p apparently is, or I'm sorry, here let me do a equals 1/4p. So that means -1/2 equals your p distance 1/4 p. So that means -4p equals 2, and then once you divide, that'll be -1/2 right there. This one's kind of a pain to graph here because our p value is 1/2. We're going to have to start dealing with half units and stuff like that. Now, since your a is negative, that means, and it's a y equals graph, that means it's going to be opening downward. A is negative, and you have y equals this opening downward here with a p value of 1/2. So let's go ahead and plot our vertex at -4, -3. And then half a unit down, and here let me use a smaller font. So half a unit down should be where your focus is. Let me tighten this vertex up here a little bit. Okay, so there you go so far. Now your LR distance, LR should be 4 times your P, which really the P should be a positive number because it's a distance here, so I'm going to take that negative off. But basically 4 times 1/2, that should be 2, which means 2 total units long. So we can do 1 unit on each side. I'm going to put a point there and a point there, and that should be enough to get your graph. See if I make this other side look a little bit better. There we go. Your directrix will go 1/2 the other way. So I do a little dotted line kind of like that right there. That's your directrix. And I guess that's at the line y equals, that's kind of like between 2 and 3, so I guess negative 2.5. And then you'll be good to go. So domain, negative infinity to infinity, range goes down forever, so negative infinity, and then all the way up to negative 3. And then, yeah, let's say the directrix is at, what's that, y equals negative 2.5. There you go, and that's all the different things there. If you want to list out your focus, sometimes the different tests and quizzes will actually ask for the focus point. So if you're doing the focus point there, I guess we kind of estimate where that is. That looks like that's at negative 4, and then that's kind of at 3.5, I guess, or negative 3.5. So yeah, let's go negative 4 and then negative 3.5, just in case you need to list it out. And there you go. Okay. Next one here, give us the equation. You got the 1/6 right there. So let's see here. That'll be, it's an x equals graph right here. If it's x equals, we know h and k are switched around. Then don't forget your opposite sign inside. So that'd be 4, negative 1. Okay. Your axis of symmetry, that will be going through the y piece on these. So at y equals negative 1. It's always tied to the y value. Your p-value, this one will be a little weird here. But you're going to get 1/6 right there. And then equals 1 over 4p. And when you cross multiply, you get 4p equals, I guess, 6. Or actually, really, it's negative 4p equals 6. And then divide. And 6 over 4 reduces to 3/2, which we could also say it's like 1.5 units, which will be a little bit more useful, I think, when graphing. 1.5 units. Okay. And then since a is negative, keep in mind that this is going to open towards the left right here because of the negative 1/6. And it's x equals, so it's either left or right, and it's negative, so it's towards the left. So let's go plot that. 4, negative 1. There's your vertex. Your focus is 1.5 full units away. Or I guess I shouldn't say 1.5 full, but 1.5 units away right there. And then your directrix, if you want to go ahead and graph that, I'm going to graph that now. It's 1.5 units the other way. There you go. Your LR distance, go off to the side, that's always going to be 4 times, I guess, your p-value, 1.5, which comes out to 6. So I've have some students that recognize that LR is actually the reciprocal of whatever fraction you got there. So I don't know if y'all noticed that there. So if you had like 6 over 1, the reciprocal of 6 over 1 is 1 over 6. So those are actually tied together there. So apparently 6 units is that total distance. That's 3 above and then 3 below. And then that should be enough to give you your shape. And that is everything. Domain, we're going to say from negative infinity all the way up to the x piece of your vertex, so that would be 4, the bracket. And then the range is going to be up and down forever, so negative infinity to infinity. If you want to get the equation of your directrix, that's an x equals, since that was vertical, that would be, looks like a little less than 6, so I guess 5.5 or 5.5. And then your focus, let's get that as an ordered pair. That's always an ordered pair. Your focus is, looks like at 2.5, negative 1. And then there you go, those are your graphs. So you'll have a few like that in the homework where you have to come up and graph everything and get all your different pieces right there. I think this next section, if I remember correctly, sometimes they're going to ask us to create an equation based off of the different points on the graph. And each of these can vary slightly. Sometimes they're going to give you different things. Like in this case, he gave us a focus and vertex. which will be kind of nice because then we'll be able to tell what P is right away. So let's go ahead and plot them here. So we got 1 comma 6 and 1 comma 4. So 1 comma 6, if I'm counting that right, that'd be right there, and then 1 comma 4. And I'm going to label one with an F for the focus, and then I'm going to label the other one V for the vertex, and that way I kind of know which way this thing opens here. So if the focus is above the vertex, that means it needs to open up eventually. So now I know I need a y equals type of graph. I need a y equals, and then I need my x squared eventually. Since my distance here is 2 full units, I'm going to say P is equal to 2, and then I'm going to say my A value is 1 over 4 times your P value, which is 1 over 4 times 2. And then that's useful because then I can get the number out in front of the x, or out in front of the parentheses. Apparently A is going to be 1/8. So that'd be 1/8, and then we'll need a bunch of stuff like x minus something squared and then plus k. So the other thing I need is my vertex. So that's your h and k, and then we'll plug those in there. So we'll go x minus 1, and then I guess plus 4. Let me scoot that. And that's your equation right there. That's how you come up with an equation. So the sketch kind of helps us get everything else. And just so I have everything else, I'm going to go ahead and do my LR and practice my graphing here. So I'll go 4 times the p-value, 4 times 2, or 8. And notice that's a reciprocal of my a value, so we know we're doing it right. And that's 8 units, that's 4 on each side. So 4 to the left and 4 to the right. Oh, I think I miscounted that. And then you can sketch the rest of your graph. You can get your directrix, which should be 2 units down below. And then there's your graph that matches right there. But really, they only asked for the equation, so I kind of went above and beyond. Okay, kind of like these here, your vertex. Focus, your vertex is at 0, 0, so that means when you plug everything back in, it's going to be real clean. So let's see what's going on here. 0, 0 is your vertex. And then your focus is at 0, negative 1.5. So kind of like right there, I guess, negative 1.5. That's your focus. So that would be a p-value of, I guess, 1.5. This will let me write. Then let's say, okay, A, 1 over 4 times 1.5, which is basically going to be 1 over 6. And then we can start writing this equation. Now, since it's opening downward, and I know that because the vertex is above the focus right there, we know we need a negative value. We need a negative 1/6. And then h and k is 0 and 0, so this will just be x squared like this, and then plus 0, which is plus nothing right there, so you can just leave it kind of like that right there. That's your equation. Then I'm going to go ahead and get my LR distance. That'd be a total distance of 6, so let's go 3 on the left, and then 3 on the right. Oh, I can't count. I think this grid's like not perfectly square. It's kind of throwing me off. There you go. And draw some arrows. That keeps going forever. Okay. Vertex and focus, kind of the same thing. Hopefully, maybe they'll give us one that's an x equals graph here. I can't remember how I designed this here, but we got vertex is at, make that grid a little bigger. Vertex is at negative 2, 1. And then focus is at 1, 1. Wait. Oh, I graphed that wrong. I was looking at it. It's like, what am I doing here? Negative 2, 1. There we go. That looks better. And then apparently at 1, 1. And that's focus here and vertex there. So if you look here, that means P must be 3. So 1 over 4 times 3 is going to be 1 over 12. And that's going to be your A value. And then we'll go, and actually, since it's opening to the left, I'm messing this up here. This needs to be x equals 1/12. Remember, your h and k are kind of going to be backwards here. So if that's your h and this is your k, we're going to go minus 1 in this case. We'll go y minus 1. Y minus the k value squared, and then minus 2 outside. And if you need to relabel that, that's this piece is k, and that's h right there. And remember, you always have the opposite of your k value there. And then that is actually your equation right there. My LR distance will be the reciprocal of that A value. That'll be 12 total units, 6 above and 6 below. I think that's going to come up here to 7 and 5 right there. So very, very wide looking graph. And if you want to get your directrix, I guess 3 units the other direction. 1, 2, 3. There we go. And that's your graph right there. Once again, they didn't ask us to do the full graph, but it's kind of, good practice. All right, I think I got a couple more here. Yep, this is the last page. What makes this one a little bit different is notice the focus here. They give us the focus. They also give us the directrix, but they actually don't give us the vertex. So we're going to have to use a little bit of logic here. 0, 7 for the focus. 0, 7, that's way up here. And then the directrix is at the line y equals 1, which is, you need to know that that's a horizontal line. Now here's the thing. Your vertex is typically halfway between these points here. So if your focus is up here at 0, 7, and then this line is the line y equals 1 right there, take those, 7 and 1, add them up, divide by 2, and find the midpoint between those, or, essentially the average, which is going to happen at 4. So that means that 0, 4 is where that vertex should be. So once again, the vertex is halfway between the focus and the directrix. So your vertex is 0, 4. Based off of that, now we can go get the p-value. The p apparently is going to be 3, which after you do 1 over 4 times 3, that's 1/12. And then now we can finish this up here. Now we can write it as y equals 1/12. And then its focus is above, so it's got to be positive 1/12. I guess we'll go x minus the x piece, so x minus 0, which we can just write as x squared, and then plus 4. Then let me go back and get my LR distance actually here on this. So was that reciprocal of that, or 4 times p, 4 times 3 is 12. So that'd be 6 to the left and 6 to the right of the focus. And then there you go. So that's your equation. Most people are actually going to write their equation like this. We're at 1/12, then I guess x squared, and then plus 4. And that'll be it. Okay, last one here of this category, I guess. Vertex is at the origin, and directrix is -5 halves. So you got something going on there at 0, 0, and then at -5 halves, which is basically -2.5. This thing's not one to write. There we go. -2.5 is where your directrix is. Which means this graph's got to eventually be, I guess, kind of going like this eventually. It's going to open to the right, so that means we got a x equals, or an x equals graph. Now to figure out your p distance, it's how far from the vertex, so it's actually 2.5 units. And then I guess we need to do 1 and then 4th times 2.5. I think that's going to come out to 1/10. So yeah, we'll go y equals 1/10, and then x squared, or not x squared, actually it's not even y. We wrote x and then I messed that up there. That'll be 1/10, and then that'll be a y squared graph. And then since your vertex is at 0, 0 at the origin, you don't have anything in the parentheses or outside the parentheses. And then since it's opening towards the right, you're going to be a positive x, or a positive a value. And then your LR distance is 10, so that's 5 above and 5 below through your focus. Here's your focus. There's a point, and then there's a point. And that's all she wrote there. Alrighty, I think this is the last one here. Given this equation, what is the vertex, focus, and directrix? And really the reason we're going over this one here is you need to rewrite it like this, 1/4 and then x squared, like that. So if you don't have anything in or around the parentheses, your vertex should be 0, 0. Okay, your focus, you need your p distance for that, right? Focus, we need p, so we'll say 1/4 equals the 1/4p. 1/4p right there. Cross multiply and divide. Guess you'll get 4p equals 4 and p equals 1. Okay, which means your focus is going to be 1 unit away from your vertex. Now, as far as which way it's opening, it's a y equals and it's positive right there. So that means this graph is going to be opening up. So that focus point, that'll be 1 unit higher. That'll be at 0, 1. And then your directrix will be that horizontal line 1 unit down below, so at y equals -1, and that's below your vertex. So I believe that is everything here. They didn't ask us to graph that. Yep, so that's good. That is it for today.